Hello my dear students, welcome to chemistry class. Today, let us learn the lesson, is matter around us pure? Today we are going to learn the topics pure substances, mixtures and solution. What are pure substances? Let us see. Here are some consumables which we use in our daily life. Are these substances actually pure? So according to a common person, this may be pure. According to a common person, if there is no adulterants are added to this, we can consider these are pure substances. But according to a scientist, these are not pure substance. What is the reason? For example, milk is a mixture of fat, proteins, water, all these. So for a common person, pure means having no adulteration, no adulterant are added to this. But for a scientist, all these things are actually mixtures of different substances and hence not pure. For example, milk is actually a mixture of water, fat, proteins, etc. And you know the composition of all these substances are different. Composition of water is different from fat, it is different from proteins. So when we can say a substance is pure, when a scientist says that something is pure, it means that all the constituent particles of that substance are the same in their chemical nature. Here as we have taken the example milk, as you have seen, milk is a mixture of water, fat, proteins, etc. The chemical nature of water is different from fat, it is different from proteins. So we are taking only water, it may be pure substance if there is no adulterant. Distilled, for example, distilled water. If there are no minerals present, only H2O molecule means that is pure. But in milk contains water, its chemical nature is different from fat, its chemical nature is different from protein. So we can consider that as a mixture, not as a pure substance. Now let us see, what is the definition of a pure substance? Pure substances are defined as substances that are made of only one type of atom or only one type of molecule. A pure substance cannot be separated into other kinds of matter by any special process. These pure substances can be elements or compounds. That means they contain only one type of matter. For example, take these examples. Gold metal. So here all the gold contains all atoms made up of gold only, gold atoms. No other substances present in that. Copper, same thing. All are copper atoms. If you are considering sugar, all the substances are sugar molecules which have the molecular formula C6H12O6. All these are having same molecules. And if you are considering salt, all the molecules are NaCl molecules. So only one type of molecules are present in this salt. So we can consider salt as a pure substance. But iodized salt is not a pure substance. In that iodine also present, that is a mixture. Hydrogen gas, all these atoms are hydrogen. And diamond, all these atoms are carbon. You know, diamond is an allotrope of carbon. So how we can define a pure substance? Pure substances are defined as substances that are made of only one type of atom or only one type of molecule. These pure substances we cannot separate into other kinds of matter by physical processes. These can be elements or compounds. Now let us see what are mixtures. A mixture is a material made up of two or more different substances which are physically combined. It contains more than one substance, element and or compound mixed in any proportion. That means a mixture contains more than one substance. And these can be elements or compounds. That means all can be elements or all can be compounds, this constituents of a mixture. And a few can be elements and a few can be mixture, compounds. So mixture is a combination, that means made up of different substances. and they cannot be physically combined. They are physically combined and they can be mixed in any proportion. So you have to keep in mind 3 points. The substances are physically combined here to form a mixture, and the constituents can be mixed in any proportion, and these constituents can be elements or compounds. Different elements can be mixed, or different compounds can be mixed, or elements can be mixed with compounds. So a mixture is a material made up of two or more different substances which are physically combined. It contains more than one substance, elements and or compounds mixed in any proportion. For example, soil is a mixture. Soil contains the mud and some minerals are present in that. Water content will be there. All these are having different chemical nature. So it is a mixture of many substances. Another example, salt solution. Here you can see salt is one substance, water is one substance. Salt solution means salt mixed with water. So here there are two different substances mixed. You can give some other examples like sugar solutions, air is a mixture of different gases. All these examples we can give. Next we are going to learn types of mixtures. Here are two examples given. First one, mixture of salt and water. The other one, mixture of oil and water. So here in the first example, salt is dissolved in water. Whether we can see the salt particles here? No. Why? It is uniformly mixed here. So it is a uniform mixture. And what about oil and water? Here we can see separately what is mixed. We can see a layer of oil here, a layer of water here. And here there is a boundary between this, a clear boundary between this oil and water. And here we cannot say till here the salt, till here the water. It is uniformly mixed. So based on this, how it is mixed, how the different substances are mixed, based on this, there are two different types of mixtures. They are homogeneous mixture and heterogeneous mixture. So in these two examples, mixture of salt and water is a homogeneous mixture, and mixture of oil and water is a heterogeneous mixture. So what is a homogeneous mixture? It is a mixture in which the constituent particles are mixed uniformly and there is no clear boundaries or separation. What is a heterogeneous mixture? Here the constituent particles are not mixed uniformly and we can see the clear boundary of separation. We can see the particles also. So let us see the differences between homogeneous and heterogeneous mixtures. First difference, a mixture in which different constituents are mixed uniformly. They are called the homogeneous mixtures. In heterogeneous mixtures, the different constituents are not mixed uniformly. Another difference, in homogeneous mixture, they cannot have physically distinct parts. That means as we have seen the example of salt and water, in that mixture, we cannot see separately where are the salt particles. So they cannot have physically distinct parts. But in heterogeneous mixture, they have physically distinct parts. In homogeneous mixture, the constituents cannot be easily seen. But in heterogeneous mixture, we can see the constituents. Another difference, the constituents cannot be easily separated in the case of homogeneous mixture. But in heterogeneous mixture, the constituents can be easily separated. Now we can take the example as of homogeneous mixture. Sugar solution is a homogeneous mixture. Soda water. What is soda water? Carbon dioxide dissolved in water. And soft drinks. Vinegar. Vinegar is a mixture of acetic acid in water. Air. Air is a mixture of many gases. These are all uniformly mixed. So these all are homogeneous mixtures. What are heterogeneous mixtures examples? Sugar and sand mixture, milk, ink, paint, wood, blood, etc. So once again, Let us see what are the differences between homogeneous and heterogeneous mixtures. A mixture in which different constituents are mixed uniformly. They are called the homogeneous mixture. A mixture in which different constituents are not mixed uniformly are called heterogeneous mixtures. Homogeneous mixture, they cannot have physically distinct parts. Heterogeneous mixtures have physically distinct parts. The constituents of a homogeneous mixture cannot be easily seen. The constituents of a heterogeneous mixture can be easily seen. In homogeneous mixture, the constituents cannot be easily separated. In heterogeneous mixture, the constituents can be easily separated. And examples of homogeneous mixtures: sugar solution, soda water, soft drinks, vinegar, air, etc. Examples of heterogeneous mixtures: sugar and sand mixture, milk, ink, paint, wood, blood, etc. Now let us see what is meant by a solution. A solution is a homogeneous mixture of two or more substances. So it has two components. One is a solute and the other one is a solution. Let us see what are the solvent and solute. A solution has a solvent and a solute as its components. The component of the solution that dissolves the other component in it, usually the component present in larger amount, is called the solvent. The component of the solution that is dissolved in the solvent, usually present in lesser quantity, is called the solute. Now, usually we think of the solution as liquid that contains either a solid, liquid or gas dissolved in it. But there are also some other solutions, solid solutions or gaseous solutions. That means solid solution, more than one solid combined together, mixed together. And in gaseous solution, more than one gas mixed together. For example, alloys are mixtures of two or more metals or a metal and a non-metal and cannot be separated into their components by physical methods. So you can see the example for alloys: brass. Brass is a mixture of two metals, copper and zinc. Bronze is also a mixture of two metals, copper and tin. Steel is another alloy. It is a mixture of iron and carbon. Here iron is the metal but carbon is a non-metal. So that is a mixture of a metal and a non-metal. So alloys can be mixtures of more than one metal or metals and non-metals. So we have seen here the definition of solution. A solution is a homogeneous mixture of two or more substances. And there are two components for a solution, which are the solute and solvent. What are solvents? The substance which is present in large quantities. That means the component of the solution that dissolves the other component. That will be always present in larger quantities. They are called the solvents. Then what are solutes? The component of the solution which is dissolved in the solvent. That is called the solute. That will be usually present in lesser quantities. And we have seen different types of solution. That means solution can be in liquid form. That means a solid which is dissolved in a liquid, or liquid dissolved in liquid, or gas dissolved in liquid. For example, solid dissolved in liquid, we can take the example of sugar solution or salt solution. Sugar is a solid and water is a liquid. So sugar is dissolved in water. We are getting the sugar solution. And liquid dissolved in liquid, we can take the example of alcohol and water. Alcohol and water mix in any proportion. So that we can take it as an example of liquid dissolved in liquid. Gas dissolved in liquid, we can take the example of soda water. Carbon dioxide gas is dissolved in water. And other than this liquid in which solid, liquid or gas dissolve, we have other type of solutions also, solid solutions and gaseous solutions. Solid solutions we have seen the example alloys. What are alloys? They are the mixtures of two or more metals or a metal and a non-metal We have seen the examples: brass, bronze, steel. All these are example for alloys. What about gaseous solutions? Air. Air is a mixture of many gases. So we can consider these are gaseous solution. Next we'll see the examples of solutions. A solution of sugar in water is a solid in liquid solution. In this solution, sugar is the solute and water is the solvent. And a solution of iodine in alcohol, that is known as tincture of iodine, has iodine as a solid and the solute is the alcohol. So iodine is dissolved in the alcohol. Another example for solution, aerated drinks like soda water. So here there are the gas in liquid solutions. These contain carbon dioxide, that means a gas, as a solute, and water is the solvent. So gas is dissolved in a liquid. Another example, gaseous solution. Air. It is a mixture of gas in gas. Air is a mixture of, it is a homogeneous mixture of a number of gases. Its two main constituents are oxygen 21% and nitrogen 78%. The remaining part, the other gases, are present in very small quantities. So these all are examples of solutions. Now let us see what are the properties of a solution. A solution is a homogeneous mixture. We have seen in solution the constituent particles are uniformly mixed. So we can say that is a homogeneous mixture. Next, the particles of a solution are smaller than 1 nanometer, 1 nm. Nm means nanometer. So 1 nanometer means 10 raised to minus 9 meter in diameter. So what is 10 raised to minus 9 meter? 1 by 10 raised to 9. So you know 1 by 10 means 0.01. 1 by 100 means 1 by 10 means 0.1. 1 by 100 means 0.01. So 1 by 100, 1 by 10 raised to 9 means 0.000, like that, 8 zeros and 1. That means such a small diameter these solution particles of a solution is having. So particles of a solution are smaller than 1 nanometer. So they are so small that we cannot see by our naked eyes. Next property. Because of very small particle size, they do not scatter a beam of light passing through the solution. So the path of light is not visible in a solution. So if you are passing a beam of light through the solution, whether we can see the beam of light here, we cannot see the path of the light here. What is the reason? When we can see a beam of light, if the particles are scattering the light, we can see the beam of light in that substance. So here the particles of solution are so small that they cannot scatter the beam of light which is passing through that. As they cannot scatter the beam of light, we cannot see the beam of light passing through the solution. Actually, whether light is passing through the solution? Yes, light is passing through the solution, but we cannot see that path. What's the reason? These particles of the solution cannot scatter this light. When they can scatter the light, there should be enough size. The particle size should be big enough to scatter the light. So as the particle size in a solution is very small, they cannot scatter the light. So we cannot see the path of the light in the solution. Next one, the solute particles cannot be separated from the mixture by the process of filtration. You know, filtration means using a filter paper. Here the filtration process is shown. On a funnel, we are keeping the filter paper. If you are pouring the solution, there is no residue on the filter paper. What is meant by residue? Which is left behind. That means as the solute particles are very small, along with the liquid, that also passing through the filter paper. So we cannot see the residue on the filter paper. And one more thing, if you are keeping the solution undisturbed, if you are leaving the solution undisturbed, the solute particle do not settle down. That means the solution is stable. So what are the properties we have seen? Properties of a solution. A solution is a homogeneous mixture. The particles of a solution are smaller than 1 nanometer. 1 nanometer means 10 raised to minus 9 meter in diameter. So they cannot be seen by naked eyes. Another property, because of very small particle size, they do not scatter a beam of light passing through the solution. So the path of the light is not visible in a solution. Another property, the solute particles cannot be separated from the mixture by the process of filtration. The solute particles do not settle down when left undisturbed. That is, a solution is stable. So today we have learned the topics. What are pure substances and what are mixtures? In mixtures, we have learned two types of mixtures, homogeneous and heterogeneous mixtures. We have learned their differences also, differences between the homogeneous and heterogeneous mixtures. Then we learn what is meant by a solution. Under the solution, we have learned the topics, what is a solute, what is a solvent, and what are examples of solution, and what are the properties of solution. Hope you understood today's class. Thank you, children.